Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 21 to 24 of the Algebra 2 Common Core New York Regents exam for January 2017. Question 21 reads, Joelle has a credit card that has a 19.2 annual interest rate compounded monthly. She owes a total balance of $B after M months. Assuming she makes no payments on her account, the table below illustrates the balance she owes after M months. Question: over which interval of time is her average rate of change for the balance on her credit card account the greatest? Okay, so before we start considering the different intervals right here and what the average rate of change on those intervals are, let's go ahead and write down the formula for computing the average rate of change. Okay, so the formula for the average rate of change is as follows. So whenever you're calculating the average rate of change, I'm going to call it AROC, is always over an interval. Okay, so from an x1 interval to an x2 interval. Alright, so the average rate of change is y2 minus y1 over x2 minus x1. Now, does this formula look familiar? This is the formula for slope, your rise over run. Okay? Alright, so what we're going to do is identify the x1, y1 and x2, y2s for the respective intervals, and then their quotient will be the average rate of change or slope. Now let's consider option 1. For option 1, we are looking for the average rate of change from month 10 to month 60. So we're going from 10 to 60. In this case, this is x1 and this is x2. These are just the x's, okay? So using the formula, we're going to have the difference of the x's on the bottom. 60 is x2 minus 10 x1. And then y2 is the output when x2 is 60. So you have 60 going to 2591.9, and then you have 10 going to 1172. Okay, so if this is x1, then this is y1. You just pair them up like coordinates, x2, y2 for option 1. Okay, so let's go ahead and put in the y's, the y1 and the y2. So y2 is 2591.9 minus x1, which is 1172. Okay, if you calculate the difference, you have 28.38. That's the average rate of change from month 10 to month 60. For option 2, we're going to look for the average rate of change from 19, that's x1, to 69, that's x2. So x2 minus x1 goes on the bottom. 69, the output for 69 is 2990. And then for 19, the output is 1352. So that's y1 1352. Okay, because we have y2 minus y1. When you find the quotient, you get 32.76. For interval 3, we need to find the average rate of change from month 36. That is our x1 in this case, to 72. That's our x2. So first things first, we divide by the change in x, also known as your run, x2 minus x1. So x2 is 72 minus x1, which is 36. Now y2 is the outputs when x2 is 72. So you have 3135.8. Subtract y1, which is the output when x1 is 36. So you have 1770.8. Find the difference and then the quotient of the differences in your calculator. You get 37.92. Option 4, you're looking for the average rate of change from month 60 to 73. Okay, so there goes our x1 and x2. So we'll start by finding our run, which is the difference in the x's, x2 minus x1. And then in the numerator, 73 takes us to y2. 3186 minus 60 takes us to y1, 2591. And if you find the difference of the numerator and the denominator and divide, you have 45.77. Okay? So the question asks for the greatest average rate of change. So on which interval did we have the highest results? We can clearly see that it's in the 4th interval. Okay, so let's write down our answer. The time interval with the greatest rate of change is what? The time interval with the greatest rate, actually average, not rate of change. Rate of change is something else. With the greatest average rate of change is from 60 to 73. Answer for number 21 is option number 4. Alright, let's take a look at question 622. It says, which graph represents a cosine function with no horizontal shift, an amplitude of 2, and a period of 2 pi over 3? Now, one thing you want to remember is the orientation of your sine and cosine curves. Okay? So one thing you want to recall is that for positive sine, you have your function looking like this, like an S. For negative sine, you have the same pattern, but it goes in the opposite direction, like this. It goes downwards instead. So this is what positive sine is, and negative sine. Sine always starts from the center. And then positive cosine has this orientation, like a cup. And then negative cosine is an inverted cup, like that. Alright? So with these guidelines, we can eliminate some options here. Whichever one starts at the center, remember there are no horizontal shifts. Whichever one starts from the center does not qualify to be considered because they are sine functions. Option 1 starts from the maximum here, so this makes it a cosine function, which is good. This one is a negative cosine function, which is good. And then this one right here is a positive sine function, which we should eliminate. And this right here is a negative sine function because it starts from the center and goes down, so it's negative sine. This starts from the center and goes up, so it's positive sine. So these two can be eliminated. Alright, remember the question asks for which represents a cosine function. Now, what's the difference between these two? They both have an amplitude of 2, so that's not a difference. Amplitude is equal to 2, which basically means that you're going to go plus or minus 2 units to the max and min from the center. And we can see that behavior manifesting itself. From the center, this goes to the maximum of 2 and the minimum of negative 2. The same behavior here. Okay, so the amplitude is not what will help us determine the answer, but the period actually helps us out. We're told that the period is 2 pi over 3. Okay, so what does that mean? It means that a complete cycle, a complete cosine, positive or negative, should be 2 pi over 3 radians long. And if we take a look at this, let me go ahead and show you a complete period for all the functions provided here. So for a cosine, you started from a maximum. The next maximum is your period. So that's one complete period. Over here, this is a complete period. For the sine function, this is a complete period right here. Okay. So in essence, for each scenario, we have 3 periods going on. So this is one period, this is another one. Okay, 1, 2, 3. Now, if you notice, for option 1, 3 periods is equal to 2 pi over 3. For option 3, 3 periods is equal to 2 pi. So which one is correct? Well, let's go ahead and set up and solve a ratio. Okay, length divided by period. So the problem tells us that what? The problem tells us that the function should have a period of 2, okay, 2 pi over 3, sorry. So that means that 2 pi over 3 will be the length of one period. Okay? So since these two have 3 periods, the question is, what will be the length in radians of 3 periods? So solving this ratio will help us determine the correct answer. Okay? It's very unlikely that this will be the answer because we have 3 periods being equal to 2 pi over 3. Okay? Alright, so let's solve this out and see what happens. If we cross multiply, we'll have 2 pi over 3 times 3 equals 1 times x. The 3's divide out, and we have x is equal to 2 pi. So this tells me that the correct function will have 3 periods being equal to 2 pi radians. So take a look at the options we have here. Which one has 3 periods equal to 2 pi radians? The answer is clearly option number 3. Okay, question 23. It reads, according to a pricing website, Android phones lose 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 Android phone in 1.5 years? Okay, so let's go ahead and write down the formula for exponential decay. Okay, remember we have exponential growth and we have exponential decay. For exponential decay, the final amount is going to be the initial amount, a sub 0, times e raised to the negative r, the decay rate, times time. Okay, so in this particular problem, we have a starting value of $300. The decay rate is 58%. In decimal form, you move your decimal points to the left 2 places, 1, 2. So it's gonna 58% is equivalent to 0.58 in decimal form. Time t is 1.5 years. Okay? So the value is going to be p of 1.5. That will be determined by plugging all these values into this exponential decay function, which will be 300 times e raised to the negative r. Negative r is 0.58 times t, which is 1.5. Okay? Now, if you notice in the calculator, the only component that's simplified is just the exponential piece. Leave everything else intact. Okay? So if you multiply 0.58 and 1.5, we should get the correct answer. Let me show that to you real quick. So we have 0.58 times 1.5. We have 0.87. So the correct model will be 300 e to the negative, don't forget the negative, 0.87. So which one matches this expression right here? Our answer is clearly option number 1. Alright, let's take a look at question 24. It says a cardboard manufacturing company is building boxes with lengths represented by x plus 1, width by 5 minus x and height by x minus 1. The volume of the box is modeled by the function below. So we have this cubic function right here representing the function when you find the product of these three functions. Okay? Question: over which interval is the volume of the box changing at the fastest average rate? Okay? So one thing you want to keep in mind, I'm going to note that the average rate on an interval is basically equal to the slope. Okay? The slope of the line, the secant line through those 2 points. So that's what we're doing. We're basically looking for slopes here. So there's something I would like us to recall, which is how the magnitude of the slope of a line changes as you go from horizontal to vertical, rotating in the counterclockwise direction. Okay, so let's say we have a horizontal line right here, and this is going to be our vertex or pivot point. The slope of this line is 0. Okay, now if you go in this direction, if you go in the counterclockwise rotational direction right here, the slope of this line right here is undefined, but considering this direction, if you're approaching this vertical line from this direction, the slope is going to be approaching infinity. It's just another word for a very, very big number. The number is so big it cannot be quantified. Okay? So when you're going from 0 to an extremely large number, what is happening to your slope? Okay, so let's consider intermediate cases. So take a look at this line, and then take a look at this line right here. How do the slope of these two lines compare? If you're going from 0 to infinity, it tells you that the value is increasing. Okay, so the steeper a line is, as long as you're going up from left to right, the greater the slope, right? So when you're going counterclockwise, the slope is increasing. But when you're going from vertical to horizontal in the clockwise direction, you have a scenario where your slope is decreasing. So you have a decreasing slope. Okay? So the steeper a line is, the greater the slope, increasing from left to right. The less steep a line is, the smaller the slope, increasing from left to right. Okay? Now what we're going to do is we're going to draw our respective secant lines. Okay, our slope lines for the given intervals, and the steepest one will represent the fastest average rate because it's going to have the greatest value for the average rate of change on that interval. Okay? Alright, so let's start with question 1. 1, 2. So you're going for, this is x1 and x2 is 2 right here. So we're going to draw a line through those 2 points. It's a secant line. Let's make it nice and long. So what we're going to be doing is drawing our slope lines and comparing their steepness relative to one another. Alright, so that's line number 1. The next one we're going to draw is from the line from from 1 to 3.5. So let's make that red. So starts from this here common point here from 1 to 3.5. Where are you? Right here. 3.5 dead in the center. There goes our second line. Let's make it red. So our second line goes like that. Okay, you see that it's not as steep as line number 1, which indicates that it is going to have a smaller slope. Okay, following the direction of rotation, remember when you're going down from vertical to horizontal in the clockwise direction, your slope is decreasing. Okay, alright, next interval 1 to 1.5. So from 1 again to 5, not 1.5, 1 to 5. What does your horizontal what does your secant line look like? Let's make this one green. So we're going from here all the way to there. Wow, this is really small. It's 0. That's what the slope is. You know that is 0 because you are running without rising. So your y2 minus y1 will be 0 divided by your run, which is non-zero, and your answer will be 0. Okay? Now let's look at the last one, which is going from 0 to 3.5. So 0 on the graph to 3.5 on the graph. Let's connect the dots, draw our slope line, and compare them with one another. Okay? So draw a slope line for 4. Okay? So let's make it longer. Okay, so that one is the 4th one right there. So the question is, which one is the steepest? That will have the fastest average rate. We can clearly see that the steepest line, the one that's closest to the vertical line, is graph number 1. Okay, so this is the fastest average rate or the greatest slope in this scenario. Another way you can do it is you can find the coordinates, the x and y coordinates, and then you can use the formula average rate of change from x1 to x2. You can just compute y2 minus y1 over x2 minus x1. If you don't like using the graphical approach, you can use the numerical approach to find the slope of these secant lines over their intervals, and you will clearly see that the biggest answer will be option 1 because it is the steepest one. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful to your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback will be greatly appreciated. If you have any questions or comments about what we went over in this presentation or any algebra concept on the Regents exam in general, just place your questions in the comment section below. Do not forget to subscribe to our channel for updates to other math prep tutorials. More clips, formula, tips, and tricks can be found on mathgotserved.com. Do visit our site. Thanks again for watching and have a wonderful day. Goodbye.